In this lab, you're going to use the spatial features of Oracle Autonomous Database to help create localized pizza offers based on spatial proximity analysis. The context here, of course, is spatial. Everything happens somewhere. All the business information that we manage ultimately relates to activities, customers, incidents, events, transactions that happen somewhere. The ability to relate and analyze all that information based on location holds tremendous value. Are events or incidents located within a certain proximity of each other? Which location is nearest to something else, which is aligned with our lab here? Which pizza location is nearest to customers? Which tax zone are we in? Are we within a flood or hazard zone? And on and on and on. Oftentimes, location relationships are really the only relationships between disparate pieces of data. There's no natural key to join between in many cases. However, proximity and containment creates that association between data sets, and there's tremendous value in that. Within Oracle Autonomous Database and Oracle Autonomous Database Shared in particular, there's a set of native spatial capabilities whereby you can store spatial data, points like geocoded address locations, lines like utility alignments, polygons like sales territories, for example, natively within the database with a native data type. In addition to that, we can store, in addition to our native spatial data type, JSON representations of that data, as well as store geospatial imagery, satellite imagery, drone imagery, and so forth. Along with the ability to natively manage that kind of information, we have a vast API for processing and analyzing that information through standard SQL and PL SQL. So in the example that we see here at the top, we're able to ask a proximity question with standard SQL. Say, for example, we have policyholder locations for an insurance company in a table, and we have information about a projected hurricane path. And we can use standard SQL to identify the policyholders that are within, in this case, 10 kilometers of that projected hurricane path. Now, there's dozens and dozens of packages containing hundreds of various operators, calculations, measurements, all sorts of spatial operations that we can do natively in the database. We'll see some of these in the lab that you're going to do. There's also a no-code or self-service application that is provided along with the database to provide access to those same features for spatial data management, processing, and analysis, as well as map visualizations, creating maps. And that's something called Oracle Spatial Studio. And that's a free tool. It's available on the Oracle Cloud Marketplace, and it allows users to effectively drag and drop to select data, upload data, visualize it on a map, and do all the kinds of analyses that you would otherwise do through code in the database. Now, the very first version of the MovieStream workshop that you are working through today does not include Oracle Spatial Studio, but I wanted to make sure that you are aware of it. And at the end, when I show some links, you're going to see where you can learn more about it and get a jump start even before we introduce the second version of MovieStream. Another very important aspect of the spatial features in the database, in Autonomous Database in particular, is the fact that they live among all of the other converged features of Oracle Database. And the converged features of Oracle Database include a wide set of capabilities that go beyond the traditional forms of storing and querying relational data. So that includes, in addition to spatial, things like graph, native JSON representations, columnar data stores, native REST enablement, and so on and so forth. And the beauty here is that each of those multi-model sorts of capabilities are not built through separate specialty databases. They're all part of the Oracle database, and again, in particular, Oracle Autonomous Database. So the power of spatial really is amplified when you start to combine it and bring it together with and integrate it with these other converged capabilities. Now, there's a wide variety of, in addition to these sort of advanced multi-model capabilities, there's a wide array of just traditional powerful features of Oracle database, unique features of Oracle database that spatial is has been engineered to take advantage of seamlessly. So while these are not spatial features, they're powerful database features that spatial knows how to take advantage of. And those are things like the way that Oracle database handles partitioning. Well, spatial knows how to work with partitioning natively. So you can have spatial partitions with their native individual spatial indexes. High availability, sort of active standby. Well, Oracle Spatial is integrated with that so that you can have high availability that is sort of spatial aware. And another one I'll mention that is part of the lab that you will do is something called function-based indexes, where you can create an index on the result of a function. And that's a powerful database feature used all over the place, but spatial knows how to take advantage of it. And as you'll see when we get to the lab, you will, because it means that a function that generates geometry can be indexed. You can create a spatial index on that, and that provides a lot of value in terms of agility and the ability to index and process large amounts of spatial data without ever having to physically build a geometry column. So just to summarize some of the key resources available to you to learn more, here at the top we just have our entry point into the spatial features of the database. So this will take you to the portal from where there's all kinds of other information, documentation, and everything else available. A few details within that worth calling out. First of all, live labs. You're in the MovieStream live lab workshop, so you know about live labs, but there's 3 in particular that you could look at as well that are specifically around Oracle Spatial and Oracle Spatial Studio. So I'd encourage you to look for the workshops with those names. Ask Tom is a webinar series that are recorded, and there is a whole series of Ask Tom webinars on lots of spatial topics. So I would encourage you to follow those. And finally, we have our Oracle Spatial blog with more information, recent announcements, etc. So the lab that you're going to do is around associating customers with the nearest pizza shop location, specifically a set of pizza shops that we've entered into a partnership with for a promotion. The idea is that the machine learning exercise would come up with the customers that are at risk of churn. This lab determines for each customer which is the closest pizza shop, if there's one within a reasonable distance. And then those 2 things would be put together to basically say for the customers at risk of churn, we now know which pizza shop to create a promotion for. So what you will be doing in this lab is as follows. You're going to be working with the customer contact table and the pizza location table. Each of those includes coordinates. You're going to begin by creating a function that converts those coordinates into a geometry, just a general purpose function. You will then create some standard spatial metadata for each of those tables, metadata that's required of tables that have spatial data that's used for spatial operations in the database. You will then create a function-based spatial index on both of those tables, which I mentioned previously is a powerful database feature that spatial is able to take advantage of. And then once you've done those 3 steps, you'll run a whole host of what we call nearest neighbor spatial queries, proximity queries. And you'll see the full sort of complement of different ways in which those kinds of queries can be run. And you will, at the end of it, finally run a big nearest neighbor join query to determine the closest pizza shop for each customer when that customer is within a reasonable distance of a pizza shop location. I hope you enjoy the lab and it encourages you to look more deeply into spatial, and thank you for your attention.